Hi all, welcome to lesson 5. Today's topic is limits at infinity. And I'm going to get started with the warm-up. We are given a piecewise function. There are 3 parts to it. And I also graphed it. Now there are 2 questions being asked. So letter A says limit as x approaches 0, f of x is. So again, I'm going to reiterate the fact that our limit is basically our y value, right? As x is approaching a certain number, what's happening to my y? So as x is approaching 0 from the left, I'm going to trace it. So as x is approaching 0 from the left, oh, this is too thick. I need to reduce the thickness. So as x is approaching 0 from the left, my y value is what? 5, right? So it's 5. I'm just going to write it here, 5. As x is approaching 0 from the right, my y value is what? 2. Are the left and the right limits same? No, they're not. So what would be my answer? My answer would be the limit does not exist, right? So I'm going to write here does not exist. The next one, I'm still going to trace. Limit as x approaches 3 of f of x. So as x is approaching 3 from the left, what y value am I approaching? I'm approaching 2. From the right, what is it? It's approaching 2 again. So the limit does exist. They're both same. So it is 2. Limits at infinity. So I want you to, before you get started with this, I want you to go back and look at my video for the notes of this lesson. I made a separate video for them, and please make sure you copy those notes and have them handy in front of you because they will help you with this lesson. So let's get started. I'm just going to get started here. If y is equal to L is a horizontal asymptote. Remember, asymptotes are lines that a graph gets very, very close to but never touches. So if y equals L is a horizontal asymptote of f of x, then limit as x approaches positive or negative infinity of f of x, it's going to be L. So it's going to be your horizontal asymptote. You should be very thorough with knowing how to find a horizontal asymptotes. I gave you all the 3 scenarios in that video, so please make sure you do look at it. Okay, so I'm going to get started with example 1a. It says what happens to an expression as it approaches infinity. So I'm just going to zoom in and I'm going to start with this. I have been trying to fill out many things. You can always pause, copy it down so that the video is not too long. So it says limit as x approaches infinity, x squared plus 3. All of these questions you can actually easily answer using the graphs. If you look at the graph, it's a lot easier to answer than explain at times. So I want you to graph them and do them algebraically. Try both ways. There's not much algebra to do here. You just have to identify what's happening to my x and based on my x, what's happening to my y. So as x is approaching infinity. So as x is approaching infinity, it means it's approaching positive infinity. So it's in this direction, right? We do agree? What's happening to your y values? Isn't your y increasing? Y is also approaching what? Infinity. So your answer here would be just infinity. I can conclude here, it's a polynomial function, right? Any polynomial function, if limit x approaches positive or negative infinity, the answer will be always either positive infinity or negative infinity. So depending on what it would be. Okay. B. It says limit as x approaches negative infinity 2 plus 1 over x. Okay, I'm graphing this part of the function. I actually graphed it here. So now look at this. As x is approaching negative infinity, as my graph is going in this direction, what is happening? My y is approaching what? 0. If it is approaching positive infinity, my y is still approaching 0. So what can I conclude? If I have any constant over x of any power, that x key can be of any power, if limit x, as x approaches positive or negative infinity, that constant over x is always going to be 0. This is what I can conclude from there, right? And I just showed it to you on the graph. So here, limit of a constant is always a constant, right? We did that earlier in the thing, so it will be just 2. Plus, we know this is what? My y is approaching 0. So my answer is 2. Part C. Limit as x approaches infinity, x cubed minus 10 over 8. I use the calculator to grasp this rational expression. So I want you to have your notes that I asked you to copy in front of you, so you're able to answer this question. You should have a tentative idea of which scenario this is. If you look at how do we solve these questions, we start with looking at the degrees of the numerator and the denominator and comparing them. So if I look at the degree of the numerator, it is degree 3, and the degree of the denominator is 0 degree, right? That's just a constant. So it's safe for me to say the degree of numerator is greater than degree of denominator, right? So what can I say? You can add a placeholder, or even if you didn't have to add a placeholder and you just know from your notes, this is going to approach positive infinity. And now let's analyze the same thing graphically. Look at this. As your x values are approaching infinity, means they're going to the right, right? What's happening to your y values? Because that's what my limit is. The graph is also growing. The y values are increasing, so it is going to approach positive. Example 2, find part A, limit as x approaches negative infinity of this expression. So first thing, we are using the placeholder method for all these questions. I keep saying that. I need to compare the degrees of the numerator and the denominator. So simplify it. Even if you didn't simplify it, you can at least say, if I was to rewrite it twice, my highest degree in the numerator would be x squared, right? Or simplify it if it's an easy thing to simplify. So now let's compare. The degree of the numerator is, the degree in the numerator is a degree 2 polynomial, and in the denominator it is again the same degree 2. So I can say the degree of the numerator is same as degree of the denominator when it happens that your limit is just the coefficients of it. What's the coefficient of x squared here? 1, and in the denominator is 3. So that's your answer. Basically, it's saying you have a horizontal asymptote at y equals 1. B. Okay, so again, let's get started with comparing the degrees of the numerator and the denominator. I rewrote the question so we have enough room here to work with. So the degree of the numerator is a degree 1, and in the denominator it's degree 2. So basically I can say the degree of the numerator is less than degree of the denominator. So when it happens that, I'm just going to add a placeholder in the numerator. So what is 0 over 1? Let's work with the coefficient. 0 over 1 is what? 0. So your limit will be 0, right? I would just want to circle this actually so that you understand where it's coming from. It's the same idea for all 3 different kinds. Okay, part C. So here again, let's compare the degrees. The degree of the numerator is, it's a degree 3 in the numerator and degree 2. So degree of numerator is greater than the degree of denominator, right? You kind of should know the answer now, but let's put the placeholder and check it out completely. So here I need a placeholder in the denominator, right? So what's 1 over 0? Does not exist or is undefined. So it's going to be approaching positive infinity because x is approaching positive infinity. I also wanted to do number 5 on the practice problem. It is on the 3rd page. Here the limit is as x approaches infinity of this rational expression. Okay, so whenever you work with the rational expressions, I know we said the leading coefficients it should be. So here many people get confused that, oh my god, the 2's cancel out, it's 2 over 2 and it's 1. No, it won't be right because this is not in standard form. You want to write your x terms first. So I'm going to rewrite it in standard form or descending order. So it'll be x plus 2 over negative x plus 2, right? And now do the leading coefficients. So what is it? In the numerator, it's the same degree, so it's going to be 1 over negative 1, which is negative 1. I just want to do another one of these practice problem questions. Number 10. Here it says limit as x approaches infinity and then the functions given to you. I separated them using my properties of limits, which we did in lesson 3, I think. So let's tackle them individually. So for the first one, it's a rational expression. So first you want to start by looking at, is the numerator and the denominator have the same degree? If not, then you add the placeholder. They both have the same degree. They're both degree 1 in the numerator and the denominator. So your limit is just going to be its coefficient, which is just 2 over 1, which is 2. So for the second part, I actually graphed it also. This is an exponential function. So think about it. I'm going to talk about here as I'm graphing. As x is approaching to infinity, so as my x values are going in this direction, what's happening to my y values? They are also increasing. They are also approaching positive infinity. So this is going to be just infinity. So 2 times infinity is just infinity. So that's your final answer. Okay? And now I want you to finish the rest of the practice problems and the homework and upload it onto the Canvas website. Thank you so much.